Okay, great. So today I'll be giving you an overview of the new space economy and how that fits into the idea of building this next space age. So I think it's useful to have a little bit of historical context here on the development of space throughout the ages and where we stand now. So we're now in this age which some people call Space 4.0, which is really the dawn of a multi-agent landscape. And so this comes following periods including Space 1.0, which was the early study of astronomy and rocketry, really getting our initial bearings on what's going on out there in the cosmos. Space 2.0 being the space race, this all-encompassing geopolitical competition between the United States and the Soviet Union in the 50s and the 60s, the first moon landings. Space 3.0 being this international coordination era where we came together as nations and built the International Space Station and started developing the first frameworks on the UN level for space policy and space governance. And now we come to Space 4.0. And the reason why we call it a multi-agent landscape is because it's really a time of global interaction between national space agencies, but also private companies and now even citizens, including things like the space economy, space tourism, access to space opening up to regular people through companies like Virgin Galactic now, of course, space exploration, and the increasing vital importance of developing good space governance frameworks. So within this 4.0 context, there is an idea called new space. And there are different ways of thinking about new space. It's not exactly one thing. So one way to define new space is to look at it as the emergence and growth of space startups since around 2010. And you can see here on the right, really the amount of investment that's been going into a very rapidly increasing number of companies in an increasing range of diversity of different technologies and applications has been almost exponential and looks like it will continue to do so for the next decade ahead. Another way to think about it is a design philosophy. And this is a design philosophy which aims to develop space technology in both faster and in more cost-effective ways than traditional aerospace companies have done in the past decades. And so this involves cheaper, faster time to market, more software-centric focus rather than hardware, greater focus on flexibility and modularity rather than extreme reliability or scalability focus, taking on missions that are both high risk and low risk, but not only focusing on the big moonshots, and of course the funding and the activities coming not only from government and big corporations, but also from small enterprises, startups. A third way to think about it is using commercial off-the-shelf components, which are pieces of hardware that can be bought, which are standardized at a relatively affordable cost, and then integrated into various different missions. And so this enables really a disruptive innovation strategy, which lets new entrants come in with a disruptive trajectory and eventually overtake the incumbents' sustaining strategy by offering a lower cost at a lower performance, but then using profits to reinvest into R&D and increasing performance and then actually being the market leader. And so SpaceX is a good example of this. Initially, their rockets were not that reliable, were not as high performance as, of course, large space agencies. But through this disruptive innovation strategy, they were able to overtake those incumbents by really increasing their performance and reliability to now industry-leading standards. And finally, we can note that this entire new space trend has been enabled by the rise of low-cost launch vehicles, such as, for example, through SpaceX's reusable rockets, the Falcon 9s and the Falcon Heavies, which can re-land on re-entry, and their boosters can be reused many, many times. I think some of them have been used over 10 times now for various different missions, and small satellites. And for small satellites, there's a form factor called the CubeSat, which you can see a diagram of here on the top right, which is essentially units of 10 by 10 by 10 centimeters that are relatively modular, that you can design and modify for different types of missions, including different payloads, different types of solar panels, communications devices, etc. And here you can see actually this dramatic decrease in the cost of launching things into space, which was in the tens of thousands of dollars in the 1980s with the space shuttle, to now thousands of dollars with the Falcon 9, and under $1,000 with the Falcon Heavy, and soon coming to hundreds. And this really opens up access to space for so many different applications, not just commercial, but also scientific and private things like being able to go to space, stay in a hotel, go around the moon, all sorts of very exciting things coming up. So in terms of that new space trend, how does that actually convert into an economy, and what does that value chain look like? So one thing to note before we get into this is that space is about things in orbit and around it, but it's equally about things on Earth. And so here on the right, you can see that satellites and UAVs, unmanned aerial vehicles at high altitudes, and drones all have pretty similar capabilities of imaging the Earth from above. And this is an important perspective to keep in mind when we think about space as being a multi-layer environment. And so the way that this converts into a value chain is, as you can see here, this idea of things being built, launched into space, collecting some sort of data, whether it's direct Earth imagery or radar data or telecommunication signals being sent, downlinking that data back down to Earth, analyzing that data, putting it through machine learning algorithms, processing, storage, security, all that stuff, and then developing a final product, which actually has potentially hundreds of different applications across all of the industries that we find on Earth. So things like location tracking, monitoring environments, ecosystems, monitoring the flow of resources, insights for financial investments, for legal, for property tech, mapping out for disaster relief, all sorts of different things. And then finally, we get to that layer, which is explore. And so the value chain from build to product can be seen as an inward focus using space for Earth, whereas the explore part is outward looking, is, okay, what is the next frontier? And here we have things that come into play like space infrastructure, tourism, resources, and exploration. So one thing that I did when I was at Seraphim Capital was map out actually the landscape of what this new space economy looks like. And we were really one of the first to do this because it was quite nascent. And not a lot of research was being done at the time into how this all looks when it comes together as a value chain. And so we mapped out the most innovative and successful venture-funded companies, divided them into the upstream section, the downstream section, and then that beyond Earth layer, which includes explore. So you've got that flow of the value chain from build all the way down to explore. And then allocated them into subcategories, which represents the different groups of technologies and applications that they fit into. So this was first designed in 2018, and it really became an industry standard. We started seeing space agencies using it, other funds, companies, and various different events using it. And so we decided that we would make this a yearly thing and update it. And so you can see here the 2019 version, already more companies coming in. The 2020 version, really a significant growth in the number of satellites, launch companies, analytics companies, products, exploration companies, and finally the 2021 version. And so to look at the comparison here, you can see a significant expansion in just the last 4 years in the number of successful venture-funded companies, some of which have gone on to actually IPO or be acquired by larger companies, and in the diversity of different companies as well. So it's becoming very competitive. And of course, we might be seeing some consolidation in these markets in the coming decade as the winners arise and the ones who are less competitive end up folding or being acquired or whatever else. But it's great to see this diversity of different options popping up for technologies and for applications. So in terms of the categories of these different technologies and applications, we can highlight things like space hardware, software and engineering, materials and energy, and electronics and robotics on the build side, launch vehicles, services, and flight and delivery on the launch side, different satellites, including satellite constellations on the data side, such as for Earth observation, telecommunications, or Internet of Things networks, drones and UAVs doing a similar thing, but at a lower altitude. On the downlink side, the communications aspect, ground terminals, which are actually receiving those signals, and ground stations, which are processing the incoming signals and storing them. The security and storage infrastructure and software around this, cybersecurity, quantum cryptography, all these key technologies are being developed now. On the analyze side, we can look at both the Earth observation data analytics, but also the drone data analytics, and in fact, the data fusion of those two together to build even more multi-layered, even richer insights for various different downstream applications. On the product side, we have, as I mentioned, location, tracking, mapping, monitoring, and some of these products you are all familiar with, such as Google Maps and Earth, Citymapper, Uber, Deliveroo. All of these things that use GPS and satellite imagery are fundamentally reliant on space infrastructure. And so they do form a part of this new space economy in the wider sense. And then we get to explore, which, as I mentioned, includes space infrastructure, like space stations and refueling stations and so on, but also space research, things like microgravity research and in-orbit manufacturing, space resources, things like asteroid mining or using space-based energy, constructing fields of solar panels in space that might actually go a long way to solving our energy problems on Earth. And then the space exploration aspect, including both the tourism, but also the settlement onto other bodies like the Moon, Mars, and deep space stations. So some of the star companies that I can highlight in these areas, and this is difficult to do because there's a lot of great ones. All of the ones on the map are worth looking at, but these are some of the really big ones that have gotten the most attention or the most funding. So for example, on the build and launch side, we have Oxford Space Systems, just a few kilometers south of Oxford here in Harwell campus, which produces deployable antennas. So antennas that actually are small when you put them into satellite, but then deploy into a larger array in space. We have NanoRacks, for example, which has a CubeSat deployment device on the ISS, and also does mission services, integration, operation testing, all of this ecosystem around the actual rockets and the launch infrastructure. We have, of course, SpaceX, as you're all familiar with. So here, the historic Falcon Heavy launch that happened a couple of years ago, which is now the lowest cost rocket per kilogram on Earth, and will soon be superseded by the Starship that SpaceX is developing. And other companies in that space like Blue Origin, Virgin Orbit Rocket Lab, Relativity Space, which is creating 3D printed rockets in this device that they call a Stargate. So potentially very disruptive in terms of the flexibility and cost effectiveness of building launch vehicles. And then finally, Reaction Engines, which is a very interesting one, also based in Harwell campus down here in Oxford, which is developing air-breathing engines that will allow us to create space planes. And space planes, to some extent, fix the issue of the reusability and high costs of rockets in that they can launch straight from Earth, operate through the atmosphere, but then also operate in the vacuum of space. And so this is something that's in development. It will take a decade or two, but it will be very interesting to see what sorts of applications that opens up in the space domain. On the data and the downlink side, we have massive constellations of satellites, such as Planet Labs, Spire Global, doing Earth imagery for things like weather forecasting, maritime tracking, aircraft tracking, and so on. On the right here, you can see some imagery of Washington, D.C. From Planet Labs itself. We probably can't see Mark on there, but it has many interesting applications for land cover analysis, environmental analysis, looking at the flow of traffic, etc. We have many, many more of these constellations that I can't highlight in full, but then we also have companies like SpaceX launching telecommunications constellations. So the Starlink constellation, which many of you have probably heard of, is aiming to have tens of thousands of satellites in orbit to offer low-cost global connectivity. Similarly, Hyber and others are doing that on the IoT side of things. And then we have companies like Minarek, for example, developing laser communications, which are fast, secure, and high speed in terms of the high data throughput, both from satellites to other satellites and satellites down to Earth, but also between aircraft, between ground stations, etc. So interesting to see the communications side of things growing as well. Then we have analyze and product companies. So these are really focused on the core analytics, the machine learning algorithms that are parsing through all this dense imagery and trying to extract insights, actionable insights from them. So Orbital Insight, for example, you can see here on the top left, has many different applications from buildings to railways, to land, to ships, to airplanes, to housing developments, to looking at oil tanks and trying to see how much oil reserves are there, and therefore trying to forecast the future prices of oil for financial organizations. We have Hummingbird, for example, doing that with drone analytics on the right, Google Earth and Google Maps, which you are familiar with on the bottom left, and companies like What3Words and Mapbox doing kind of mapping applications. And so what 3 words is, for example, dividing the entire planet into squares of, I think it's 3 by 3 meters or something, and allocating 3 words to each square, such that with any 3 words, you can find the exact location on Earth. So again, like really interesting applications that without this space infrastructure would potentially not have emerged.
Bartu, I think he has 2 questions in the chat.
Sure. Do you want me to address questions now or at some later point?
However you like. I just wanted to let you know.
Okay, great. I think it's probably easier if I do it later since we have limited time now.
All right.
But I will address them very happily. So on the Explore side, we have, again, SpaceX, which shows up in so many of these segments. But of course, their plans to develop a Mars colony, a Mars settlement is a large aspirational drive for the rest of the economy. And the Starship is being developed specifically with that in mind. Virgin Galactic now, which has IPO'd on the New York Stock Exchange, enabling low-cost tourism soon into the stratosphere to see the Earth from above. Companies like Astroscale and D-Orbit, which are tasked with removing space debris. So again, the issue here of space sustainability comes into play. Other companies like Bigelow Aerospace and Axiom Space, developing parts for commercial space stations or expansions to the ISS, which is very important because the ISS at the moment is the only place that we have in orbit that humans can go to. So increasing our resilience in that respect and having multiple different stations around the Earth will be a very important stepping stone to developing this wider low Earth orbit economy. And then others like Made in Space and Space Tango, doing things in orbit manufacturing, pharmaceutical research, microgravity research, etc. So where does the European Space Agency fit into all this, since we are in Europe after all? And in fact, the ESA Space Solutions, which is the Program for Space Innovation, is also based here in Harwell campus, south of Oxford. And so they do they have two different programmatic branches, which help to promote innovation in space in Europe. One being the business incubation centers, with locations all across Europe, and thousands of startups being incubated to date. And then the second is business applications, which provides funding for feasibility studies and demonstration projects for various different projects that wants to use space for downstream applications. And so really the focus is to improving life on Earth. And the only thing a company has to do to be eligible for these programs is to use at least one space asset. And so on the bottom here, you can see the different types of space assets, including direct spaceflight technologies, but also communications, navigation, Earth observation, and space weather related things. So there's a great portfolio that's arising out of this European Space Agency activity, and it covers really many different funding themes, from smart cities to environmental monitoring, maritime, agriculture, 5G, healthcare, railways, green buildings, virtual reality, and many, many others. And if you're interested in seeing the diversity of different funding teams that they have, you can go on their website and look at the different funding calls, and they have a really nice kind of introduction to each of these areas. Some highlights from the European Space Agency portfolio. When I was there, I also designed this map of the ESA Space Solutions landscape because I really like maps. So some include Lilium, for example, which is basically a flying car, an electric vertical takeoff and landing aircraft. Minaric, which I mentioned, D-Orbit, Open Cosmos, which does mission design, integration, etc. Hyber, which I mentioned, the Internet of Things company, connecting satellites to devices all around the Earth for low cost, low energy. Resitech, which does Earth observation data analytics for resources, forestry, etc. ClearSpace, which is a space debris removal company, and Solar Foods, which is a pretty interesting one, actually. It develops sustainable protein for both Earth applications, but also for the future of our exploration in space, because we will be needing low energy and sustainable sources of food when we embark on missions to the moon and to Mars and further. There's also the idea of spin-off technologies here. So there's a great amount of technology transfer being done from Earth to space, but also from space to Earth. So you have applications which come from satellites, such as solar energy cell development or non-pressurized gas, which are being used on industries on Earth now. Air circulation systems, which were developed for the ISS, now being used in offices on Earth. Water purification, sustainable foods, insect farming technologies, which have been tested on the ISS. Medical plasma technology, which is being used in hospitals around the world, which initially came from R&D for space. Chemical sensors, and many, many other such examples. And the economic return on investment for any given investment into space has been found to be really incredible, from 7 to 14x returns. And so this really highlights the importance of keeping a healthy space budget, both at the national levels, but also in the international coordination level, because we derive so much value from this as a human society and as a global economy. I think it's important also to think about things through a systems thinking perspective. And so there are many different layers and scopes of systems that we can include in this perspective. So there's the organizational ecosystem, including public agencies, but also the commercial sector, how startups and large corporates are interacting, how they are interacting with funding bodies, how they are interacting with civil society, and the interests of different diverse groups of people giving their input into how we expand into space. We have the launch and re-entry system, the Earth observation system, from the very beginning of building stuff all the way down to bringing that data back down to Earth. Same with telecommunications. We have the low Earth orbit economy system, all of the infrastructure that goes into that, refueling stations, etc. We have the Earth, Moon, Mars exploration system, stops on the way, like the Deep Space Gateway, different technological development that needs to happen, the amount of resilience and reliability that we need to reach in our technologies to enable each step of the way there. And that enables the wider space exploration system, which then depends on the space governance system around that, and which all connects to the super system. And the super system just means the widest scope of them all, which is human civilization. How does this fit into our objectives as a human civilization? And are we taking the right steps to get to the right places in sustainable ways, in resilient ways, and in inclusive ways that bring together nations to work together? In terms of Mars settlement, I can highlight a few technologies that will be relevant to develop. So there's the launch infrastructure to get there, but also the bases to land there, radiation shielding for buildings, energy efficiency, closed loop life supports, which we are already seeing on the ISS, manufacturing solar panels at a very high cost effectiveness, and using in situ resources. So using the sand and the sun that is already found on Mars, for example, vertical farming technologies, battery technology, clean transportation that you can actually use on Mars, things like hydrogen fuel cells, for example, and R&D into new materials, more resilient, more radiation hardened, and cheaper to produce materials, especially with the very limited resources that we will have somewhere like a Mars base. And so finally, in terms of the next space age, what are the future trends that we should be looking out for, both as entrepreneurs, but also as people involved in civil society, in the public side of things, etc. So there's space sustainability, space debris removal, for example, being a major driver there. Space as critical infrastructure, the idea that we depend so dearly on GPS, Earth observation, telecommunications, etc., and making sure that we are protecting that infrastructure from both outside threats like space weather, but also from hostile threats between different actors that are earthbound. Satellite-based 5G connectivity, which is coming very soon. So enabling really much greater and much higher speed connectivity between devices all over the Earth, and also internet connectivity. Connected vehicles, as self-driving vehicles become a standard, we will need them to be connected to satellites so that they always have positional information and they are able to adjust and also be connected to other cars on the roads to make sure that everything is flowing as smoothly as possible. Real-time video from space, real-time ability to see changes in urban environments, in natural environments, and being able to track that over time, and also being able to broadcast that to the world, showing people this is the perspective that you can have on the planet from space. Distributed AI systems in actual space systems, so in satellites, in ground stations, in the processing, in parallel processing to make things more effective. Satellite servicing and refueling, so actually going up with various spacecraft, such as companies like Momentus and Deorbit are developing now, and either refueling or maintaining satellites that are at the end of their life so that they don't turn into space debris and cause space sustainability issues. New rockets being built, Starship on SpaceX's side, New Glenn on the Blue Origin side, the SLS that NASA has been working on for a while. Space planes like the Skylon, like reaction engines that I mentioned, is developing Skylon. Sierra Nevada in the US is developing the Dream Chaser. So these space planes that can both emerge from the atmosphere and into the vacuum of space might be really disruptive. In-orbit research and manufacturing, commercial space stations, space-based energy of all sorts, asteroid mining, space tourism, this dynamic of the second space race, this new geopolitical dynamic, which might have some parallels with the first space race in the 50s and the 60s, Moon Village, Mars settlement, how space law and space policy fits into all that, the emergence of astropolitics to be an extension of geopolitics, and then looking more into the future, existential risks that arise out of our expansion into space, and how we are designing governance frameworks that mitigate those risks, and then strategically, where we are going as a civilization, which directions we want to expand in, making sure that we have an aligned vision and roadmap for the development of this new space economy. So that's it from me. It's a lot of material, but happy to take any of your questions. You can get in touch with me at my email or on LinkedIn or whatever else. Always happy to have a chat. Thank you very much.
Bartu, thank you. As you said, a huge amount of material, a rich range. I know everyone is just digesting. I want to also note all the comments and questions in the chat. What I'd like to do is, again, first of all, just celebrate Bartu. Thank you for compiling an enormous amount of information. We'll see many of these actors and firms and agencies over the next 8 sessions. Many people on the call have direct expertise. So in a sense, our work is to begin to figure out how to access that expertise within the group here and digest it and share it. So